When computers started to be produced by different brands, each brand designed their own rules. As a result, an incompatibility problem occurred between these different brands. Before 1963, computers had many different ways of describing characters. Therefore, computers not belonging to the same brand could not communicate with each other. The importance of this question began to emerge as large companies like IBM began to scale up their computer networks. In May 1961, Bob Banner, an IBM engineer, sent a proposal to American National Standard Institute (ANSI) to develop a single code for common computer communication. As a result, American Standard Code for Information Interchange, which is ASCII code, began to be used as a common language for computers. The basic requirement here was that each of the 128 characters must have a fixed numerical value. This code was obtained by rearranging the symbols and characters which used in telegrams by the Bell Company at that time. At first only included capital letters and numbers, but in 1967 was added the lowercase letters and some control characters. So, with this set of only 128 characters was published in 1967 as a standard, containing all you need to write in English language. After a while, ASCII codes were expanded to 8 bits because 7 bits were insufficient. In 1981, IBM developed an extension of 7-bit ASCII code. With this way, 128 characters were added with new symbols, signs, graphics, and Latin letters, all punctuation, signs, and characters needed to write text in other languages. In this way, ASCII characters upgraded the capacity from 128 to 255. IBM includes support for this ASCII code in the hardware of this first personal computer. The operating system of this mode, the MS-DOS, also used this extended ASCII code. After that, almost all computer systems use the ASCII code to represent characters and text. Now we can look how a symbol entered on the keyboard is converted through ASCII code in a way that the computer can understand. And we already know how to convert the binary number system to decimal number system. As we know, the smallest of data unit is the bit that represents with 0 or 1. Each 0 or 1 is equal to 1 bit. A byte is a unit of data consisting of bit values. Every 8 bits is 1 byte, and each character typed on the computer corresponds to 1 byte of data. On the right side of the screen, you can see the biggest and smallest total value obtained using these 8 numbers. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is equal to 255. 255 is the biggest number and 0 is the smallest number, as you know. You can calculate all numbers from 0 to 255 by this way. So, for example, the name of my website securelations.com consists of 17 characters, and it occupies 17 bytes of space on the hard disk. There are many characters we can type on the keyboard, but computers only understand information represented by 0 and 1, because everything in the computer memory is stored in binary number format. For example, a computer cannot know what the capital A character means. These characters are represented by a binary digits 0 and 1 in the computer. Each of these characters are shown as 7-bit codes. Now it's time to work on it a little more detail. The standard ASCII code defines 128 characters code from 0 to 127. The first 32 are control codes and the other 96 are representable characters. For different operating systems, representing the standard ASCII code have same 8-bit code. The extended ASCII code defines 128 extra character codes from 129 to 255. For different operating systems, representing the extended ASCII code have different 8-bit code. For capital letter A, let's look how to use the ASCII code. Capital letter A is a standard ASCII code, and for different operating systems, capital letter A has the same 8-bit code. For doing this, you must engage the keypad. First find and hold the Fn key, and press the numlock key. But some laptop keypads do not have numlock key, so using the numeric keyboard makes your work easier. First press the Alt key on the keyboard and do not let go. While press Alt key on your keyboard, type number 65, which is the capital letter A in ASCII table. Then stop pressing the Alt key, and you got it. As you see that ASCII code to represent the capital letter A is always represented by 65, with the binary notation as 01, 00, 0001. Now it's time to get smaller letter A. First press the Alt key on the keyboard and do not let go again. While press Alt key on your keyboard, type number 97, which is a small letter A in ASCII table. And then stop pressing the Alt key, and it's OK. As you see that ASCII code to represent the small letter A is always represented by 97. with the binary notation as 01100001. Now you know how data is translated in a way that computers can understand and how data is entered with the help of a keyboard. Hexadecimal is the name of numbering system that in base 16. This system therefore has numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We want to show all these numbers as a single digits. For this reason we use the capital letters A, B, C, D, E and F instead of numbers 10, 12, 11, 13, 14, 15. Here is the number system for hexadecimal numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, capital A, capital B, capital C, capital D, capital E and capital F. For better understanding the hexadecimal numbers, you can use a table on the screen. This table is organized to be easily read in hexadecimal numbers. Row numbers represent the first digit and the column numbers represent the second digit. And the prefix 0x is used in code to indicate that the number is an hexadecimal number. For example, the capital A letter is located at the third row and the first column, so it will be represented as hexadecimal number 0x41. The small a character is located at the sixth row and the first column, so it will be represented as hexadecimal number 0x61. With these calculations, we have also reviewed the binary, decimal and hexadecimal number systems. As you can see, the basis of understanding technology is the correct use of fundamental science. If you are learning something new, take it step by step without rushing. Don't forget that the stronger you build information, the durable you build your structure.